All right, everybody, welcome back. We are diving deep today, and it's going to be CFD.
CFD.
I know what you're thinking.
Yeah.
Computational Fluid Dynamics. Sounds a little dry, right?
A little bit, yeah.
But trust me on this one. This is really cool stuff.
It is.
It's basically like having X-ray vision, but for anything that flows. So we're talking liquids, we're talking gases.
Exactly.
All that good stuff.
Okay.
So to kick us off, why don't you tell us what is CFD? Really? Like, how would you explain this to somebody who has never heard of it?
Well, you can think of it as a way of using really powerful computers to simulate how liquids and gases behave, how they flow, how they interact with things.
Okay.
It's kind of like a virtual wind tunnel, but a lot more versatile.
Okay, that makes sense. So we all know what fluids are.
Right.
You know, had a milkshake earlier, so that counts.
Sure.
But how do you do dynamics with a computer? That doesn't really make sense to me. It's not like you can just pour water into a digital container.
Right. That's a great question, and it gets to the heart of what makes CFD so powerful. So imagine you take a fluid like air flowing around a car, and you break it down into millions of tiny little pieces. It's almost like creating a digital 3D grid. And then you can use some pretty complex math to figure out how each of these little pieces moves and how it interacts with everything around it.
So instead of actually building a car and putting it in a wind tunnel, you just make a digital version and see how the air flows around it on the computer.
Exactly.
That's really cool.
And this is where it gets really interesting. Let's say you're designing an airplane wing. With CFD, you can experiment with all sorts of different shapes and see how those shapes affect things like lift and drag.
Okay.
In fact, CFD has actually helped engineers discover that just adding tiny little winglets to the tips of airplane wings can reduce fuel consumption by like 5%.
Wow.
Yeah, that's a lot.
That's a lot of fuel and a lot of money.
Exactly. It saves money. It's better for the planet.
Yeah, definitely. And you know, it's not just about designing things. I was reading in some of the material we have here that CFD can be used to understand really complex phenomena like turbulence.
Yes.
Now, I always thought turbulence was just, random chaos. How can you possibly make sense of that using a computer?
Well, turbulence is definitely chaotic, but CFD helps us take all that chaos and turn it into a pattern that we can understand. We can analyze it.
Oh, okay.
And that knowledge is incredibly valuable because it leads to safer and more efficient designs for everything from airplanes to pipelines.
Wow. So they can actually predict when you're going to hit a rough patch of air on an airplane.
Kind of, yeah. They're getting better and better at that.
That's reassuring.
It is. It's a lot safer now than it used to be.
That's good. So we talked about airplanes a little bit. What are some other ways that CFD is being used? I mean, it sounds like it's everywhere.
It really is. Think about designing a Formula One race car. With CFD, you can figure out exactly where to tweak the design to make the car go just a little bit faster. Yeah, just a few milliseconds can make all the difference.
Yeah, in that sport, I guess so.
Absolutely. But it's not just about speed. Think about the design of airplanes.
Okay.
Those sleek, futuristic-looking planes that just seem to glide through the air?
Yeah.
They're designed that way for a reason. CFD helps engineers figure out how to minimize drag so the planes use less fuel and produce fewer emissions.
So it's not just about looks, it's about being more efficient.
Form follows function.
There you go.
Yeah.
And it's really amazing how, air resistance, it's invisible,
Right.
but it has such a huge impact on everything.
So what about other fields? I know that CFD is used in a lot more than just cars and airplanes.
Oh yeah, absolutely. For example, meteorologists use CFD to predict weather patterns and study how climate change is impacting our world.
Okay.
So they can actually see how air currents move around mountains or how heat gets trapped in cities. And that helps them make more accurate predictions.
That's really cool. Architects use it too, right? To make sure buildings don't fall over. Absolutely. CFD helps them design buildings that can withstand really strong winds and make sure that the ventilation systems work properly.
That makes sense.
Yeah, but one of the most fascinating applications, I think, is in medicine.
Oh yeah, I read about that. They're actually using CFD to look at blood flow
Yes.
in the human body.
That's right.
That's amazing.
So imagine being able to design better heart valves or understand how blood clots form.
Right.
CFD is really changing how we diagnose and treat all sorts of diseases.
So from what we've talked about, CFD is kind of like this hidden force that's shaping the world all around us. It's not just pretty pictures on a computer. It's about understanding these invisible forces that control how things move.
Right. And it's leading to all sorts of amazing innovations and solutions in every field you can imagine.
Yeah, so it's like CFD is giving us this superpower to see things that we normally couldn't see and understand these complex processes.
I like that. A superpower with endless potential.
Makes me wonder, what else can CFD do in the future? What other big problems can it solve? I mean, we talked about a lot of cool stuff, but I'm sure there's way more out there.
Absolutely. The possibilities are really endless.
It's just incredible to think that something that started out as, complex math and equations can actually have this kind of impact on our world.
That's the beauty of science. You never know where it's going to lead you or what kind of questions it's going to help you answer. And with CFD, we're really just getting started.
Well, I am definitely going to be looking into this more because this is just fascinating. Who knows? Maybe one day I'll even understand all the math behind it.
You never know. And the most important thing is just to stay curious and keep exploring.
Absolutely. All right. Well, thanks for joining us for this deep dive.
My pleasure.
We'll catch you next time.
See you then.